Welcome to qnawire.
So in this question, we're given the electron affinity, which I've denoted chi subscript E for chlorine. We're also given the energy input required to separate K plus and Cl minus ions from separate K and Cl atoms. And then we're asked to work out the ionization energy of K. So by definition, the electron affinity is the amount of energy released when an electron is attached to a neutral atom to form a negative ion. So we can mathematically express this as, well, we have our neutral chlorine atom, Cl, plus an electron, E minus, and that is equivalent to Cl minus, which is our chlorine ion, plus the electron affinity, which in this case is 3.6 electron volts. We can also write down a similar type of expression with this energy input here. So we have our individual atoms, K plus Cl, so that's our potassium and our chlorine atoms, and that will go to plus our energy input, which is 0.7 electron volts, and that will go to our ions. So we have K plus Cl minus. So in order to work out the ionization energy of potassium here, we need to remove any dependence of both the chlorine atom and the chlorine ion from this expression. So what we'll do is we'll equate the Cl minus terms from both of these equations here. So from the topmost equation, we have Cl minus, and that goes to, well, we have Cl, the atom, plus the electron, plus the electron affinity, 3.6 electron volts. Doing the same for the second equation, we have, well, Cl minus, and that goes to, moving the K plus to the other side, we have K plus Cl plus our input energy, 0.7. So from the first equation, we have, well, Cl minus, and that will go to, and all we need to do is move this 3.6 to the other side. So we have Cl plus E minus our electron affinity, 3.6. Doing the same for the second equation, we have Cl minus, that goes to, and all we want to do is move this K plus to the other side. So we have K plus Cl plus 0.7, and then it will be minus K plus. So equating the two, we end up with Cl plus E minus 3.6 goes to K plus Cl plus 0.7 minus K plus. And from here, our Cl terms will cancel. And now what we want to do is, on one side, we want to have our ion and our electron, and on the other side will be everything else. So we have, taking this K plus to the other side, we have K plus our electron, E minus, and that goes to, well, we want to take our 3.6 electron volts to the other side, leaving us with K, the atom term, plus, well, 0.7 plus 3.6 electron volts gives us 4.3. So now we have an expression that describes a neutral atom of potassium being ionized by an input energy of 4.3 electron volts to split this atom up into, or to ionize the atom into an ion and a residual electron. Therefore, our ionization energy, which we will call EI, is equal to 4.3 electron volts.